Dear colleagues, I'm glad to welcome you in the Eternal City. If we translate Eternal City into Latin, it sounds like Roma Aeterna. If we look at the transcription of the word Aeterna and change just a couple of letters, we get the word Artemia. So now we get the phrase that Artemia is eternal. In geological and tectonic terms, the study area is located in the Kulunda Depression, which is southeastern part of the West Siberian platform. The lakes of Kulunda Steppe are basins of ancient origin and belong to the type of single endorheic, deeply incised ponds, mostly mineralized. The source of salt formation in the lakes are sandy silty soils, formed as a result of mechanical destruction of metamorphic and igneous rocks of Altai, demolition and subsequent deposition of transferred particles by meltwater of the glacier. The Great Yarovoye Lake is the deepest basin of the central Kulunda Depression. The depth of the lake basin is 25 meters. The volume of the lake is 404 cubic meters. Mirror area is 72 square kilometers. Average depth is 5.6 meters. Maximum depth is 9.5 meters. Coastline length 31 kilometers. Maximum width 8 kilometers. Maximum length is 11 kilometers. The lake has a shape of an ellipse, stretched from the northeast to the southeast. Southern, northern and western coasts are steep. The coast of the eastern part is gentle. At the foot of the coast there are outlets of groundwater. Along the entire coastline there are sandy beaches, from 1 to 5 meters wide. The lake with such characteristics is the most favorable for harvesting Artemia cysts. The shape of the lake had no dependence on the wind direction in the weather balance of the lake, which has no tributary of the river. The main role is played by atmospheric precipitation and groundwater runoff. The area of the Great Yarovoye Lake is characterized by a sharp continental climate, long harsh winters, hot dry summers and short transitional seasons with unstable weather, spring and autumn. The average duration of the warm period with a stable above zero temperature is 190–200 days. With its onset in mid-April and end in the last decade of October, the duration of the cold period is 165–170 days. In winter, the lake is covered with thick ice. The growing season, on average, begins in the last decade of April and lasts mainly until the second decade of October. Usually, by the middle of the second decade of June, an equalization of the temperature regime over a reservoir of half-meter, 4 meters layers is noted. The temperature of the 8 meters layers does not always reach 10–15 degrees. The temperature regime of the reservoir in different years is shown in graphs from 1 to 4. Based on predominant anions in brine, the lake is classified as a chloride by its nature. General natural mineralization of the Great Yarovoye Lake fluctuates between 150–165 grams per liter. Artemia from the Great Yarovoye Lake is parthenogenetic species. Over 22 years of monitoring studies of the lake, it has been noted that 1 year the development of 4 generations was observed, but generally it was 2–3 generations. The number of generations, their numerical characteristics, the number of sexually mature females and their fertility are certainly determined by the availability of feed, which is ultimately the main factor in the formation of the seasonal stock of cysts. The analysis of the numerical characteristics of Artemia crustacean for matured groups indicates that a lake of this nature has high productivity in case the total number of these age groups is the range of 1,000–1,200 pieces per cubic meter. The optimal number of Artemia at the mature stage of development is 500–700 pieces per cubic meter. In addition, it's very important that such numbers are formed during the period when the transparency of the lake is less than 2–3 meters or during the period of a new outbreak of phytoplankton. There are 3 such periods. The first period is May. The second period is the end of July, early August. The third period is after 10th of September. The numerical characteristics of the population by year are given in the tables and graphs of the following slides. The graphs clearly show the dependence of the growth and development of the generation on feed supply. When analyzing the reproduction cycles of Artemia, it should be noted that they are correlate in time in such a way that emergence of young is timed to coincide with periods of the best feed supply. Considering the form of reproduction, it should be noted that over the entire observation period, the highest percentage of the live birth was observed in the first generation of crustacean and did not exceed 20–25%. With a balanced number of crustacean and food supply, the average egg sac usually contains 120–150 cysts. The maximum number of cysts in the egg sac was 270. During the period when the transparency of the reservoir reaches 5–6 meters, the egg sac is generally not formed, and only a few females may have about 20–30 cysts in the egg sac. The feed and species composition greatly influenced the generation characteristics. With a good supply of feed, especially phytoplankton, Artemia population of the Great Yarovoye Lake is characterized by an female-male ratio of 1000:1, 400:1. With the decrease in food supply, the appearance of males is observed. The female-to-male ratio can reach values of 100:1, 25:1. The data is presented on the slide. Observing males over 23 years of research, it was noted that they did not have seed material, and only twice, in 2014 and 2023, males with seed materials were detected. Presumably, in these years, the appearance of males with seed material was caused by formation of unusual plankton in the lake, blue-green algae, cyanobacteria. The whitish color of crustacean was evident, and an uncharacteristic degree of filling of the esophagus and an insufficient degree of digestion were noted also. With the drop in temperature and the establishment of the rainy period in the middle of August 2023, the situation of the lake changed. The mass death of the crustacean stopped. The survival rate of the crustacean during this period was about 50%. The second generation, with a population of 1,200 pieces per cubic meter, produced more than 1,000 tons in the period from mid-August till the end of October. The volume of egg laying alone was estimated at approximately 280–310 tons. It is important to note that the appearance of males in fairly large numbers in the parthenogenetic population was noted in the experiments of the Russian scientist Anikin in 1896 while studying the crustacean Artemia from the Muromshan lakes of the Altai region. He did not find males in the lake, but they appeared in indoor cultures only during periods when unfavorable conditions of the life of the crustaceans arose. He notes that it was difficult to decide which conditions were unfavorable for them, and notes that there was quite enough food. In their solutions, monads of red and green colors floated in huge quantities, and luxurious cultures of macrococci, also red and green, developed on the walls of the vessel. It is likely that the bad living conditions, as the author noted, should be attributed to the species composition or presence of a separate class of algae that are toxic to the crustacean. That's why we can conclude that the organism of Artemia crustacean resorts to this last way in order to increase the chances of the preserving its offspring. It's interesting, of course, to study the genetic characteristics of the population during the period of individual generations. What other feature of this period should also be paid attention to? In the process of collecting cysts from a number of lakes in the Altai region and Kazakhstan in some years, the presence of the light cyst was established. Usually a cyst has an almost spherical shape, but upon decapsulation it's clear that the embryo has a rather concave surface. Between the embryo and the chorion there is a space, which in fresh water ensures the buoyancy of the cyst. It is difficult to name the reason of appearance of such cysts. It has been noted that appearance of such cyst is associated with a change in the characteristics of the lake, and as in 2023 of the Great Yarovoye Lake, the appearance of not typical algae, blue-green, and the appearance of large numbers of males with seed material. There is also a low survival rate of the crustacean Artemia in adult age groups. In the harvested products of the end of August and the first 10 days of September, the presence of the light cyst changed from 10 to 30%. Over the years, the average annual supply of cysts, which was not always related to the number of generations in the lake, was estimated from 900 to 1,500 tons. The main feature of productivity of generation is the balance between the number and the food supply. The collection of cyst on the lake is carried out only from the surface, the reservoir, due to the orography of the lake. The collection of brine shrimp eggs from the surface in the coastal zone. The collection from any point of the lake using mechanical harvesting facilities. The main volume of the harvest is produced from August to October. There are two main factors that equally influence to the harvest volume: the supply of cyst in the lake and weather conditions. The main weather factors: lack of precipitation, steady wind of one direction at speed of 2–3 meters per second, significant changes in atmospheric pressure. All of the above conditions, as well as the period of active discharge of the cyst, affects the Artemia cyst supply. For example, in September in 2023, cysts were collected from two accumulations with a volume of 141 tons and 192 tons. In some years, the volume of cysts in clusters reached 250–300 tons. Usually, cysts harvested from the large formed clusters have high-quality indicators. The slide shows data on the cyst stock in the reservoir and the volumes of the procurement over the past 10 years. It is important to note the problem of the unreasonably low volume of cysts recommended for harvesting and allocated by federal authorities relative to the annual supply of cysts in the lake. The existing procedure for allocating quotas often leads to significantly underestimated harvest volumes. As a result, the enterprise is faced with large amounts of shells in the first batches of harvest. The balance of number of Artemia crustacean and the feed component is disrupted, especially in the first generation. In addition, the terms of growth and development increase. A population with low fertility rates is formed. Ultimately, this negatively affects for the formation of the supply of Artemia cysts. Siberian cysts, including cysts from the Great Yarovoye Lake, have a certain specificity. With a low basic percentage of hatching, they have a high percentage of hatching when using activators of various classes that perform catalytic functions in the process of biochemical oxidation. According to the established parameters, the duration of diapause varies. The average period of diapause is 5–6 months. Sometimes an increase in hatching in batches can be observed up to 10–12 months. When analyzing the data on the duration of diapause and the condition of existence of the generation, it should be noted that the cysts produced during the period of 2–1 generations and formed in June–July have a shorter diapause and a higher percentage of hatching. This observation is possibly associated with different nutritional prosperities of the phytoplankton formed during this period. In this regard, there is a clear system of accounting and formation of batches according to timing, volume, and location of procurement. This allows for a fairly high-quality assessment of the progress of diapause in batches. The main factor that makes it possible to decide to end diapause and begin processing is when the cyst reaches the maximum reserve of the hatching rate and to minimum concentration of the activator and remain at the same level for 10–20 days. Data on the course of diapause are presented in tables and graphs provided the slides. In case the timing of the end of diapause is set correctly and the technological parameters of drying correspond to the required indicators, the quality of the finished dry product has a consistently high hatching percentage. In some years of the processing, more than 80% of the dry product was obtained with a hatching rate of more than 85%. The confirmation can be seen on this slide. General characteristics of Artemia cyst. The maximum percentage of cysts have a diameter in the range of 220–230 microns. The corian has a dark color if the cysts are produced in July–August. The light color of the corian is usually observed in cysts produced in the autumn. The average CPG is 220,000 – 240,000. Naupli incubated from cysts of the Great Yarovoye lake have a characteristic bright orange color, with an average size of 480–500 microns. Harvesting and processing of Artemia cysts in the Great Yarovoye lake has been carried out by Arsal LLC since 1996. Monitoring studies have been carried out in full strength by the company's laboratory since 2001. Arsal's experience, location, specifics of the lake, systematization of all material and its analysis allow our team to have consistently high quality of products. There are still unresolved issues at the federal level related to the assessment of the stock and forecasting the volume of production of Artemia cyst for the current year, since it's based on an early forecast with a one-year lead. It is amazing how complex this small crustacean is, which scientists around the world have been studying for more than 130 years, and how much remains unclear. Perhaps, with the help of artificial intelligence, which allows us to identify and adapt information, we will be able to recognize those features and patterns that are difficult to explain today. But we are convinced, according to the Russian proverb, a journey 1,000 miles begins with a single step. Dear friends, thank you for your attention. I also would like to say many thanks personally to Patrick Sorgelos, the staff of GSL Cooperative, Jan Bo, the staff of INVI and Arsal Company for their support and understanding.